record this computer. Now I've started recording. This is another part, interference. Okay, before that I have done question banks, lectures, everything is done. Or what, sine waves and other stuff. Yeah, sonometers and all. Now the word interfere itself tells you everything. Like, why are you interfering in my matter? Like Hamria people. Okay, so just say, okay, interference. You live in Hamria? You don't. Good. You live in Hamria? Who lives in Hamria from here? Mariam. Okay. You see. Anyway, in Oman, to Hamria people has a very different this thing status. Okay, let's continue. And most peaceful people are from Mathura and smartest also. That's both. Okay, now interference. When two waves produces a pattern of maxima and minima where waves combine constructively. We already did it, by the way, interference. You know the superposition we did last time? Yes. You have another name known as, I think, what is anybody saying me anything? I can't hear, by the way. No. Today tuition at 8. Tuition at 8. Today's tuition is at what? 6 to 8. What the hell? You're supposed to join. You're not there. I can join karo jaldi. Hello. ভাইয়া কি ডাউনলোড করতাম যে ভিডিওস গুলোর আমি লিংক পাঠাচ্ছি 4 o'clock. No, sorry, 2 o'clock. Okay. Marwa, you are supposed to download all the videos and not delete them. Download and keep a copy with yourself. Okay. Fine. Okay, ma. Interference sound. Let's talk about interference of sound. You have two speakers. You have two speakers connected to a single signal generator. Single signal generator. That means both the speaker will have same coherent waves. You know what the meaning of coherent waves? Yes. They have the same. I told you, I gave you a definition. Same constant phase relationship. The definition is same constant phase relationship. They both are same type of wave. Both the speakers are giving sound waves. They have the same amplitude. They have the same wavelength. Understood? They both are same. When they are going to interfere in this region, they are going to interfere in this region over here. Can you see? Okay. At the center of the speaker, okay, Mehak is joining in 2 minutes. Let me not go ahead. No, she'll not understand anything. Just let me pause the recording. Okay, I'm starting again from division a bit. So you have two speakers. They both are emitting coherent waves. You know what the meaning of coherent waves, right? Yes. The waves which have constant phase relationship. That is, and they have same. They are same type of wave. They have same wavelength and same frequency. Okay, so now what happens is that you have signal. They are connected to same signal generator. That means they both the speaker emit same type of wave. Okay, now if you walk around with a this thing microphone, or if you walk around in that area, you will see at the center of both the speaker you're going to hear a loud noise. At the center of both the speaker you're going to hear a loud. Just after that, some distance apart, you're going to hear a quiet, and after quiet, you're going not hear. I mean, you're going to observe that it's quiet in that region, and after that, you're going to observe again another loud region. So this is the center. After each loud, there is a quiet, and after each quiet, there is a loud. Okay, this is what you're going to observe. You can ask me questions, but yeah, in whenever there is function in our school, and we have this huge speaker, you know that those two speakers we always use. Okay, so those two speakers, what happens to those? Like, do they? Why don't we? Some parents hear the sound, some parents doesn't hear the sound. Okay, does that happen in our functions in school? I will say no, because when they are singing or when they say something, the frequency is not same all the time. The frequency is what? Varying. So তোমার complete interference হচ্ছে না. Complete interference what কি? Completely constructive and completely destructive interference হচ্ছে না. It is partially. So everybody can hear. But if they both emit same tone of voice, same frequency of voice, they will cancel each other out at some place, and they will add each other at some place. Why? Because of phase and antiphase. You guys already know the concept of phase and antiphase. Okay, সবাই কি বুঝছো তো না এটা? সবাই আমি কি বলার চেষ্টা করতেছি এখানে? এখানে হচ্ছেটা কি? All you understood? So now Two identical loudspeakers are placed in a large room which are connected to signal generator. Both the speakers emit coherent waves, which means both the waves have same frequency and constant, I underlined, constant phase relationship. This is the definition of coherent waves you guys are supposed to remember. Same type of wave, same amplitude, same frequency, same wavelength, and same constant phase relationship. Now, when an observer walks across the room, in front of the speaker, region quite loud can be observed. Regions of quite loud can be observed. In loud region, waves are traveling in phase. Phase মানে কত? 360 degree অথবা 0 degree. So constructive interference takes place. In quiet region, waves are out na কি লিখছি নতুন anti phase. Don't write out of phase from now on. So destructive interference. Now, this particular thing you can ignore. Okay, this particular thing you can ignore. Let me explain. I think I will still explain a bit of it, but you don't have to learn the whole thing. Okay, so this is how it is. Let's talk about this. Okay, now I will say the meaning of path difference. Before me saying the concept of path difference, I already explained it to you. Now, path difference is given in lambda and phase difference is given in radians, in pi. Phase difference is written in radians and path difference is written in lambda. Okay, so what's happening here? What's happening here? Now, at this, okay, when the actually when the path difference, okay, is a whole wavelength মানে কি 0 lambda. When the path difference is whole wavelength মানে whole number, 1 lambda, 2 lambda, 3 lambda, 4 lambda, 0 lambda, 6 lambda, whatever, as long as it's a whole number. When the path difference, okay, before explaining path difference, let me explain some difference for you guys. Like for example, this is my from home, let's say this is my home. Okay, I'm going towards the school. Okay, I'm reaching school and let's say it is 20 kilometer. Okay, and for example there is another guy who lives in, let's say what, Kurum. Okay, yeah, he is going, and let's say from Kurum, let's say it's 15 kilometer. Okay, what's the path difference here? What's the difference in their path? They travel 5 kilometers. Basically, the distance from here to here minus the distance from here to here. Understood the difference? This is what we call path difference. Let me tell you what is the path. What is the path difference in terms of waves mean? Okay, I'll try to explain you as simple as possible. Something is wrong with my PDF. It's taking too much time to write. Okay, fine. So, for example, a wave from here is reaching towards the center, and a wave from here is also reaching towards the center. Since this is the center, let's say the path difference here is lambda and path difference here is lambda. Okay, they both are same. One minus the other is going to be what? Zero. So path difference at the center is 0 lambda. Remember that. Path difference at the center is always 0 lambda. And let's talk about the first loud over here. Path difference of the loud is always, I'll give you guys a formula, but it's always a whole wavelength. Maybe it is 1 lambda. It's a 1 lambda. Understood? This is 1 lambda. You guys are supposed to know this. All of you got it? Okay. In between, I think if I remember, it is 0.5 lambda in between. Here, in between both the loud. See, this is loud, this is loud. In between both the loud, there is going to be always a region of quiet. So this is going to be 0.5 lambda or half a lambda. Okay. Loud is always whole wavelength. Okay. And quiet is always in decimal, 0.5, 1.5, 3.5, 4.5. It's like that. Or 3/2, 7/2, 5/2, like that. Okay, and loud is always what? Constructive. Quiet is always destructive, interference. We will not say superposition here. We are going to say interference. To be honest, if you say superposition or interference, it's okay. But in school, sometimes some teachers, they don't accept. In school, for standing waves, you have to use superposition, and for light waves, you have to use light. You have to use interference. Okay. So now let's talk about over here what's going on. What they wrote. What is the path? This is the formula for path difference. The difference in distance from each sources to a particular point. So from one, this is your source, okay? And this is that particular point. So from your source to a particular point, this is your source speaker number one, and this is your speaker number two. How much is the difference in their path is what we call path difference. So let's see, let's say this is P1. Huh? Look, S2 P1 minus S1 P1. Everyone got it?
Yes.
Okay, fine then. Let's continue now. Uh, this thing, Mehak, understood? What is path difference? Mehak, Salma, Sujata, understood?
Yeah.
Salma, Sujata, understood?
Yes.
Yes, yes.
Fine. Let's continue now. So what about this? Say when the path difference is zero, when the path difference is zero, or whole number of wavelength, whole number mani ki 1 lambda, 2 lambda, 3 lambda, 4 lambda, like that. When the path difference is zero or whole wavelength, the waves are in phase. We know what is in phase, and this constructive interference takes place. This position is of maximum amplitude. 3 marks right there. We call loud ki hoy maximum amplitude. When the path difference is odd half a wavelength, the waves are odd half a wavelength mani ki jano lambda by 2. Okay, 1 lambda, 3 lambda by 2, 5 lambda by 2, 7 lambda by 2. You understand? Where you have an odd number in bottom 2. Okay, and our pi radians out of phase, destructive interference takes place. You know pi radian mani ki 180 degree out of phase. So then the path difference is what? Odd half a wavelength. Odd half a wavelength মানে কি তোমার কোয়াইটের মধ্যে তোমার path difference সবসময় divide by 2 থাকবে কোনো একটা lambda. 3 lambda divided by 2, 5 lambda divided by 2, 7 lambda, something like that. Let's see whether this is correct or not. I have some other ways to find it as well. Um, yeah, in this one, there are some formulas I was supposed to write for you all. Do I have this formula here? Wait. Okay, n plus half lambda. Okay, I'll give you guys the formula and all everything. What is it? 0. Yeah, fine. Now interference pattern at a ripple tank. Okay, now how many of you here knows has this compass with them? How many of you here has compass with them? Just check. Let me pause the recording. See, I'll show you guys a rough diagram here how it is done. Okay, or maybe I'll try to find some online compass tool to show you all. Okay, I'll try that. Let me pause the video. Okay, so now I'm going to show you the what happens in water ripples when two water ripples interfere each other. Okay, so you have two ripples over here. Okay, so I will show over here with the help of their wavelengths and all. Okay, with the help of their wavelengths and all, the same wavelength I need here and there. Okay, so let's see, and I'll try to maintain the same wavelength. Okay, over here.
Okay.
I know it will take some time, but still. Okay, fine. Now let me keep it here again. I'm sorry. Wait.
On drugs.
Yeah, it's really hard to control. Okay, no, not an issue. Yes, now I'll go much more further than that. Fine, lock it. Okay, so this is how you're supposed to. Oh, sorry. I'm drawing water ripples over here to show you constructive and destructive interference and all. Okay. So you know how water ripples are, right?
Yes.
Okay, so I'm drawing that. So this is you guys can do this practically, na? If you guys got the compass with you right now. Okay, because I wanted to record and I wanted everybody to see it. That's the reason I did this. Now let's go much more further a bit. Lock it. Yeah, you can go home and you can check. Online people, everybody's seeing this now properly.
Yes.
Guys, Sujata and everyone.
Yes.
Okay, fine. So this is how you're supposed to draw them. I didn't know this existed in the first place. So, oh yeah. Okay, so now I think I'm almost done over here. Let me pause the recording. Let me just make further plan over here. So now I hope they give me, okay, blue color. Oh, no, not this one. I don't need it. I need straight lines. Okay. So if you see this blue color line which I'm drawing right now, okay, can you see wherever the construction is taking place, there you have these lines over there. Wherever these are lines of what? Constructive superposition. And in between you have destructive superposition. See, wherever it is crossing, can you see those crossing over here?
Yes.
All of you? So these are regions of constructive interference. Okay, in between we have regions of destructive interference as well. This is where does this happen, by the way? This happens in water ripples, in water waves and all. So this is one way. You can imagine you have two sources over here. Like in ripple tanks, you have two sources over here, and they are the water is traveling, and both the source water, what they're doing, they are interfering each other. So what's happening here? You have constructive and destructive. You have crest and crest, constructive. You have crest and trough, destructive. You have trough and trough, constructive. Okay, let me show you. Remember in between both the constructive interference, there is actually a destructive interference taking place. Remember that. Yeah, in between, see this two line, blue line.
Yes.
In between you actually have dotted lines. In our exam papers we'll have dotted lines over here. So this is what's happening here. They are, the green lines are, the dotted lines are what? Destructive interference. Remember we saw in the sound waves, you have loud and quiet, then loud and then quiet.
Yes.
Yeah, and the center one is always loud. Here same thing, center one is constructive, after that it is constructive. In between both the constructive there is a destructive interference. Online, everyone clear?
Where is the loudest?
At the center.
Yeah, that's right.
Loudest is always at the center. Everyone online understood the concept over here, how to sketch the lines of water ripple tanks, when two ripple tanks, when they diffract. Yeah, two sources when they interfere, this is how it looks like. Everyone, is it clear with you guys? I'm changing the screen. Is it clear?
Yes.
Okay.
Clear.
Okay, so now they're saying interference in the ripple tank over here. You guys can go home and you guys can actually revise this, taking your compass, you can draw it very well. 6:35. Okay, can you please send the records of the esters? I think it's already uploaded. It's already uploaded, most probably. Check it. Okay, an interference pattern can be observed using a ripple tank. Circular wave fronts, you know what, which one is the wave fronts, no? The one which I drew with the compass, those are wave fronts. Okay, are generated by two prongs. You know what are those prongs which vibrates in the ripple tank? Okay, you have two, this thing, circular, semicircular, not sorry, spherical shape, small bob kind of. They vibrate, and when they vibrate, it produces waves for you in ripple tank.
Okay.
I call it bobs. I don't know why. Okay, now, oh, not that. Okay, where trough from one source, look there, when where the trough from one source meets the trough from other source, or crest meets the crest, then maximum constructive interference. Okay, calm water indicates, if there is a calm in between, indicates that the destructive interference where the trough meets the crest. Yes. Now what I'm going to do is, I'm going to do right now, I'm going to show you how does an actual water look like. What I just showed you, just diagram and constructive and interference and destructive in terms of diagram. I'm going to show you an actual water, this thing, interference. Let me pause the video. So look at this over here. Or if you can see, these are some examples of interference that is occur in our water waves. You can see yourself, look what's happening. You have, this is constructive. Can you see this constructive? And in between, can you see this calm region? This is destructive. And this is constructive. This is constructive. In between you have a destructive region. Understood? Water interference. Everybody got this? Okay, fine then. Now let's talk about, okay, water interference done. Sound waves interference is done. Now let's talk about light interference. And remember that 6 mark thing I showed you guys, 3 marks. I told you now. So you have to write about constructive interference. What do you have to write? You have to write maximum amplitude, part differences, whole wavelength. Okay, completely in phase. 3 marks. Completely in phase, maximum amplitude, constructive interference takes place for loud noise. For quiet, destructive interference, zero amplitude, odd half a wavelength apart. Odd half a wavelength. Therefore, ki hoy? Destructive interference. 180 degree anti-phase. You know what is anti-phase, na? Destructive interference. এগুলো লিখতে হবে তোমাকে 6 মার্কের।
আগে লিখতে হবে না যে দে ডাইফ্রেক্ট।
না ডাইফ্র্যাক্টটা পরে। ওটা যদি সিচুয়েশন উপর, ওটা কমপ্লিট ডাইফ্র্যাক্টরটা ওখানে ডাইফ্র্যাক্ট হচ্ছে কিনা
ওটা লিখতে হবে না।
হ্যাঁ লিখতে হবে যদি if you need it. Now we are going to learn about interference of light. Now we are going to learn about interference of light. Okay. It is hard to observe the interference with the light. You know why light is? Because light cannot be diffracted properly. Like for example, if you have a water waves, okay, if you have a water waves, for example, what will happen? এখানেও diffraction হবে, এখানেও diffraction হবে, diffraction হবে, diffraction হবে, diffraction হবে. Just now we saw na what happens in water waves. So water waves are easily diffracted. Why? Because they have very high wavelength. The wavelength অনেক high থাকে. And when does a diffraction occur? Diffraction occur when your wavelength is equal to your gap. Remember that from O levels? When the wavelength is equal or when the wavelength is more than the gap, that term diffraction takes place. I think I already explained that to you detail as well. Okay, so light waves is not possible because the wavelength of light wave is very, very small. So you also need that space to be very small. So light waves are not that easily diffracted. Why? Because the wavelengths are very small. কি হবে জানো? তুমি যদি কোনো গ্যাপ দাও, if you put any gap over there in front of a light, it just passes through. Why? Because its wavelength is so small. It passes through without any diffraction. It is hard to observe interference with the light sources because of short wavelength, okay, and difficult to provide coherent sources. Most of the lights are not coherent. Laser light is coherent, by the way. Laser lights are coherent. Okay, so wait, my power is going. You have resumed recording? Fine. So these are some things you guys are supposed to know how to label. So what is the এটাকে আমরা কি বলি? Young's double slit experiment. Young's double slit experiment. You have a laser light. You have a laser light. Sorry. Now I tell you. You have a laser light. You have a card. I'm going to show you something like card. I'm going to show you this experiment in videos as well. Okay. And in between, you have very tiny gaps. We call them slit. Okay. This is exactly like something like this. If you see the bird eye view, okay, this is how it looks like. Those red color thing you guys are seeing now. Wait, let me show you guys with the blue color boundary and all. This is your blue color boundary. Okay. And this in between, which gap you see, those are the red color. So what happens? What happens? The laser light passes through. The laser light passes through like this. And what happens? It diffracts in the slit. Duta slit ase, just like the water wave. Na, I showed you guys. Remember? Ekhano same to same hocche. So at the end of the day, what's happening here? Interference pattern. What do we call this? Light interference pattern. So center one glows the most. I'm going to show you guys this video as well. Center one glows the most. As you go further, the glow decreases. As you go down or as you go up, it doesn't matter. The glow is going to decrease. Everybody got this? Online. You have Young's double slit experiment. Everybody got it or not?
একদম লাস্টে
Yes, understood.
I'll show you. Galib, done? I mean, you understood? Rafiq,
Yes,
Galib,
yes.
Sujata, Panna, Marwa. Shoy butsu kila bolo.
Yes.
Yes, understood.
Okay, now let me show you guys how does a laser interference look like. Let me pause the video. Okay, so these are some examples of laser interference you guys can see over here. Can you see the center one is the brightest over here?
Yeah.
And as you go left, there is a gap. If you zoom in, between each bright spot, you have a gap. So the bright one we call maxima in laser light. We call it maxima. And the one which is in between two maxima, we call it minima.
Maximum the constructive.
Maxima is constructive, minima is destructive. Center one is the brightest. Everyone got this? How does a laser interference? Even same also. This is also an example of interference, but this is a different kind of interference. This is an electron. Interfere kore na? This is something like that. I taught you in last chapter. How does an electron diffraction interference? Diffraction pattern of an electron behaving like a wave. Yeah, like that. Okay, so this is like that. See, center one is the brightest. As you go further, there is a gap. So gaps are minima, and the ones which you can see are maxima. Understood? Duita maxima majkhane gap. There is a gap.
Minima.
That is minima. Duita minima majkhane maxima.
Maximum.
Everyone, is this interference pattern understood of a laser light?
Yeah, understand.
Online, everyone?
Yes.
Okay. Remember the central, we call it central maxima. The central maxima is known as 0 lambda. I already told you that. Central maxima is 0 lambda. Okay. First maxima is what? Half lambda. Okay. Second maxima is 2 lambda. Okay. So look, this is a kind of thing that is not 100% clear. One thing is there, but the trick which I'm going to teach you is going to work 100% of the time. 100% guaranteed. Okay. This is if they do if they give you second maxima and they want you to find the part difference of second maxima, always minus 0.5 for it. Second maxima is tomorrow khuje, always minus 0.5. If they ask you 100, sorry, not minus maxima, minima. If it is 100th maxima, 100 lambda is the part difference. If it is 15th maxima, 50 lambda is the part difference. Okay. If they ask you what is the part difference of 50th maxima, you have to say what? 50 lambda.
50 lambda.
But if they say you 50 minima, 50th minima, মানে 15 number minimum মধ্যে wavelength কত, part difference কত? তুমি লিখবে 49.5. It's always minus 0.5. But when you do calculation, you have to do add plus 0.5 somewhere over here. If they ask you, no, if you write it down somewhere, you just write n plus half lambda. But I always do it minus. Actually, this comes correct. I don't know why. I'm going to explain this later. First, let us go ahead now. What's happening? Or you guys can label this now. You guys learn how to label it. Prathame central maxima. Central maximum niche thake first maxima. First minima. Erpore ki thake? Second maxima. Erpore ki thakbe? Second minima. যেখানে minima ওটা ওই নাম্বারের minus 0.5 লিখতে হবে তোমাকে. Okay? Like what? First minimum, what did I write? 1 minus half. How much is it? Half lambda. আমি যদি থার্ড মিনিমা লিখি, সেকেন্ড মিনিমা লিখি এখানে, দ্যাট মিন্স সেকেন্ড মিনিমা না, সেকেন্ড ম্যাক্সিমার পরে কি আসবে? সেকেন্ড মিনিমা। সেকেন্ড মিনিমা ইজ গোইং টু বি 3/2. why? 1.5 lambda, 2 minus 0.5. ওকে, এখানে আমরা মাইনাস করব, আর ওখানে ফর্মুলা দেখাতে গেলে আমরা প্লাস করি সবসময়। ফর্মুলা দেখাতে গেলে ক্যালকুলেশনের সময় করব না কিন্তু। ওকে, দ্যাট আই এম গোইং টু শো ইউ। ইটস আ ট্রিক। I still don't get it how it doesn't work. থাকবে, থাকতে হবে যে, নাহলে তুমি ফেল যাবে। আমার কোনো এখানে ওটা নেই। I'm teaching you the trick. I'm teaching you the trick over here. Okay? দাও, সমস্যা নেই। কি করে ফেলবে? Okay, now laser produces intense beam of light that have the same wavelength and they are in phase and are polarized in the same place. So they are polarized, they have the same wavelength. This is the another reason we cannot use any normal light. Laser light দিয়ে interference pattern ভালো হয়। বুঝছো? Because it's a coherent. You know what is the meaning of coherent, na? You think, what if your light is not coherent? Then you will not get complete interference. তুমি partial interference পাবে। বুঝছো? আচ্ছা, পজ করতেছি, কেউ মেসেজ দিছে, ডাউটিং হবে। Okay, so now let's continue. That is why lasers are called monochromatic. তোমরা এই ডায়াগ্রামটা বুঝছো কিনা বলো? যে সেন্টারটা 0 lambda, এরপরে মিনিমা, এরপরে ম্যাক্সিমা, এরপরে মিনিমা। যদি মিনিমা করে তাহলে ওটার পার্ট ডিফারেন্স তোমাকে -0.5 করতে হবে। যদি ম্যাক্সিমা করে যেটা আছে ওটাই। ঠিক আছে? Fine. When lasers light are passed through the double slit, okay, what happens? Diffraction occur. I just showed you this over here. Over here, can you see? When the lasers are passed through double slit, okay, there is a diffraction occurring. Then an interference pattern known as fringes are observed. This we call এটা এগুলোর নাম হচ্ছে fringes. Okay, the one which we see are known as light fringe. The one which we cannot see, গ্যাপের মাঝখানে দুইটা ম্যাক্সিমার মাঝখানে যে মিনিমা, ওটা সেপারেট নাম হচ্ছে dark fringe. Just the picture which I showed you of laser light, those are known as fringes. Those each individual box you can see here na, these are known as fringes. The one which we see are known as light fringe. The one which we cannot see are known as dark fringe. Okay, fine. Bright fringes occur at waves reaching having 0 part difference. See, 0 part difference. So waves are in phase, so constructive interference. Light fringe gulo constructive interference. A dark fringe gulo destructive. At first maxima, the path difference is lambda. I told you that. Okay, so waves are in phase and constructive interference takes place. Hence, bright fringes are observed. Shobai jano eta. Bujhe gecho line gulo. Now, between the central maxima and first maxima, no fringes or dark fringes are observed because the path difference in the regions are odd half a wavelength or pi radian out of phase and destructive interference occurs. Now, এখন তোমাদেরকে এগুলো শিখতে হবে, এক কালেক্টর সেখানে কথা ছিল না, তবু আমি নোটে দিয়ে ফেলছিলাম, বাট কাজে আসতেছে এখন. So you have to know this very well, what's happening over here. Okay, I will try to show you guys the video experiment of this young
প্রপার ভাগলে কেন হবে?
হ্যাঁ মেহেক বলো.
সরি বাই মিস্টেক.
It's getting recorded, you know that na. If the distance from the slit and the screen has increased, then fringes separation increases. Mani, distance from the slit and the screen. If you increase the screen, okay, these fringes will go further apart from each other. Understood? What that is the first point they wrote. What they wrote? Factors affecting the fringe separation. Whether the fringes will be closer together or whether they're going to be far away from each other. So that depends on many factors. One of the factor is if the distance from the slit and the screen is increased. If you increase this distance d over here, what's going to be, the fringes are going to be moving apart from each other. Fringe separation increases. Then if the slit separation is increased, fringe separation decreases. তুমি যদি এই দুইটা ডিসটেন্স বাড়ায় দাও, this is known as what? Slit separation. Slit separation বুঝছো? They both are slit na, those red color lines that do. এগুলো বাড়ায় দিলে they will come now closer together. মানে কি তোমার ম্যাক্স মিনিমা দেখা যাবে না ঠিক করে. The gap is going to be very small. Why? The fringe separation decreases if you increase the slit separation. Online, everyone understanding? Hello?
Yes.
Understood. Fine then. Then they're saying if the wavelength increases, if the wavelength of the light, you have to know, I'm going to teach you guys even regarding Vibgyor over here. Okay, I'm going to say that, don't worry. If the Vibgyor, if the wavelength increases, fringe separation also increases. This three are supposed to by heart. Okay, now let's talk about path difference formula. Listen, when it is formula for maxima, it's okay, it's n lambda. Why? First maxima 1 lambda, second maxima 2 lambda, third maxima 3 lambda, 1000 maxima 1000 lambda. But if it comes to minima, what we used to do, we used to minus it na, এখানে আমাদের কি দেখাতে হবে, plus, only while writing the formula, কিন্তু আমরা সবসময় মাইনাসই করি. Why is it? I don't know. I don't get that part. Because once I started doing minus, I'm getting my answer every situation there is. But once this formula, I found out it's n plus half lambda. It's not n plus half only. Oh, by the way, there is a lambda here. N plus half lambda. Okay. For writing, you are going to write n plus half lambda. But if they ever ask you, what is the part difference of second max minima? You write 1.5 lambda. What's up? Huh? Teacher. A formula, this formula is only for writing purposes we write for 6 mark na. When we have to, when I told you an odd half a wavelength, instead of writing odd half a wavelength, you just write n plus half lambda. That's it. No, this is better because this is given in the examination. This thing marks sheet. না না আমি ফর্মুলাটা শিওর, ওটা কিভাবে ইউজ করে আমি শিওর না, কিন্তু আমি শর্টকাট তবু খুঁজে ফেলছি। কিভাবে আমরা মাইনাসই করি সবসময়, যত লামডা যত মিনিমা ওটা কি 0.5 মাইনাস করতে হবে, বাস ওটাই। Understood? Okay, this is a formula that has been given to you. These are some. Just see whether you guys understand this sum or not. Pause recording. Record it now. So এরা বলতেছে the experiment করছে using a microwave. Okay, you have a maxima. What maxima? Fourth maximum মানে কত? 4 lambda. Okay, from the center how much was it? 41 centimeter and 60. What's the path difference? 60 minus 48, because I already showed you guys path difference formula on top. S1 P1 minus S2 P1. Okay, calculate the wavelength. So we know 4 lambda. Lambda ta এখানে নিয়ে আসলে sorry 4k, lambda কত? 3 centimeter. Everyone clear with this? Online, everyone clear with this?
Understood.
I can hear Galip.
Yes.
Yes, understood.
Yes. Okay, now I think interference is over. Doppler effect is not there in our syllabus. Yeah, Doppler effect is not there. Ultrasound is there. I think I already mentioned this to you guys that ultrasound, the audible frequency is about, sorry, the audible frequency is still 20,000 hertz. 20 hertz to 20,000 hertz. Audible frequency, fine then. Okay, pulse echo can detect. Achha, this I will see later on. Okay, so now interference is over with us now. So I will do some interference practice. After interference, we have diffraction, grating, and that will be last. Okay, so let me show you guys some interference related question. Pause the. Okay, so let's start doing this question. So what's happening here is that you have 2 speakers. Yeah, and S1 from A is 3.10 meter, and S1 from S2 from A is what, 4.00 meter. Now they said the frequency both the speakers are emitting is 567. Okay, you know this has to do something with the wavelength. Okay, so because that's why they gave you the frequency, and that's why they gave you this speed over here. I have to find wavelength. How? V is equal to f lambda, and with the help of that lambda I have to do something to show that your sound heard at A will be quiet. And when the sound heard at A is going to be quiet, if it is a minima, and when something is minima, when it's an odd, half a wavelength. When it is n plus half lambda, basically something half lambda. Okay, let's see what's happening here. Okay, first of all, let's find the path difference. Let's find the path difference. Speed of explain. Yeah, I'm explaining that now. How much mark is it, by the way? 4 marks. The amount of lines they gave is less. I'm sorry. So path difference is what? 4 minus 3.10. How much is it? 2.9. Okay.
0.9.
Okay. 0.90 key meter. Okay, let's find the wavelength now. V is equal to f lambda. V is what? 340. 340 divided by 567, right? Will give me what? Lambda. How much is it? Zero 0.5996 key meter. Okay, so now let's see what's the path difference. This is your path difference. What's your wavelength? This much. Okay, so one wavelength is 1 lambda is 0.5996. okay, so how much is 0.90 meter? How much wavelength is it then? Yeah, so if one wavelength is 0.5996, how much wavelength is 0.90 meter? So 0.90 divided by 0.5996, how much? 1.5. So it's coming close to 3/2 lambda. 3/2 lambda key antiphase, minima, 0 amplitude, therefore quiet. 4 marks.
Yeah,
Online.
3/2 lambda for it.
3/2 lambda, I have to say it's the part difference is odd half a wavelength. Money key. It's an antiphase. Antiphase, na antiphase money key. Destructive interference or destructive slow version of both. So what will happen? Zero amplitude. Therefore quiet. Online, everyone. Understood?
Yes, understood.
Panna, Maria, sorry, Mariam, Marwa, Sujata, Salma, Shoaib Utse, Rafiq, Galib.
Yes, Lucy.
Yes, yeah, understood.
Okay, so okay, can I keep also kichu? Yes, Panna also yes, fine. Chalo, so you proved it, hence proved. তোমরা লাস্ট পার্টটা বুঝছো কেন কি করছি আমি লাস্ট পার্টে একটা ওয়েভলেন্থ যদি 0.5996 থাকে তাহলে 0.90 কত ওয়েভলেন্থ it is 3 by sorry 3/2 wavelength 1.5. Okay, now they said the formation of the standing waves, now again interference জায়গায় ওরা standing waves include করে দিয়েছে. The formation of the standing waves within the concert hall may also create points where the sound waves heard loud or quiet. যদি তোমার হলের মধ্যে standing waves form হয় তাহলে কি হবে? There is going to be some region, it's going to be this thing. You can hear the sound and some you cannot. Why? Due to formation of standing waves. Standing waves কি কি থাকে? Nodes and antinodes. If it is antinodes, you are going to hear. If it is nodes, you cannot hear because they cancel each other out. The two methods used to prevent the formation of the standing waves are using soft fabrics. So they use soft fabrics in the theaters and all. Also on the walls, or using tiles placed on the wall at varying angles. So different angle or tiles rakhe the. So suggest how each of these two methods reduces the formation of standing waves. Acha, let's discuss it. Okay, let's discuss it and let me pause the video. Okay, so we discussed this answer, the B part. So we discussed that if you're using fabrics, it's going to absorb the energy. If the sound energy is absorbed, okay, there is like, let's face it, like if it gets reflects too much here and there is going to be a lot of echo, na? Yeah. So you don't want that echo to take place because then the whole performance that they are doing in the theater is no use if you cannot hear properly what they are speaking. So they have fabrics over there to absorb energy, and they have tiles. What does the tiles do? They reflect the waves away. Well, basically, usually ki hoy ekhane eshe abar wapas ekhane jay, right? That's why the standing wave is forming. So if you have a tile like this, it comes and it goes away. So they are not interfering. Understood? Or they are not superposing each other. So if you see the mark scheme, this is the answer that has been written. So see whether all the points you guys understand or not. Check. You guys can understand? Everyone? Online, everyone understood, right? Online.
Yes, yeah.
Okay. Fine then.
Yes.
Let's go to the next question now. Okay, now the microwave oven are used to cook food. Okay, microwaves are emitted. It is which year is this, by the way? Maybe same year. October 2017. Okay, microwave ovens are used to cook food. Microwaves are emitted inside the oven and reflected from the sides, forming standing waves. Fine then. One problem, okay, with using microwave oven is the formation of hot and cold spot. Basically, in your food, there are regions which become hot, and there are regions which became which is cold, which has not heated up. So you know very well it is because of nodes and antinodes. Explain how hot and cold spots are formed within the food. I think pretty easy. Just let me pause the video. You guys frame the answer for me. Just tell the answer. So we discussed the question, and we discussed the question, and this is the answer. Now let me know whether you guys are understanding all the points or not. Upar and night. Cold spots formed at node. We know that. We just discussed that. But at nodes, cold spots are forming. Okay. At nodes, what is happening? Zero amplitude.
Yes.
Okay. And because the waves are anti-phase, antinode, what happens? They are in phase, resulting in maximum amplitudes. So 3 marks right there. Clear? Online, everyone, clear? Guys, that's the next question. So they gave us this you guys will do for me. Let me see how many of you can do this on your own. Read it and do it on your own. Let me see how smart you are. Okay, so here they said, next one they said 2 adjacent hotspot. Let me show you guys this, how this is done. Look, 2 adjacent hotspot. If you draw the graph, can you see this is node, anti-node, and this is also an anti-node, and they are adjacent. Okay, 2 adjacent, this thing is what? Half a wavelength. They're what? Half a wavelength. So full wavelength kota? 2.8. Full wavelength 2.8 hobe na? So lambda here is 2.8 centimeter. Calculate the frequency. Now I have to divide by 100. We know V is equal to F lambda. V to dena hai. But it's a microwave. We know microwave speed hoche 3 into 10 to the power 8. Frequency koto? Jani na. Lambda koto? 2.8 divided by 100. Do this in your calculator. You guys will get the answer of frequency. Everyone understood? This question was a bit tricky. 2 adjacent. Oneke babbe, oh bhaiya adjacent mane node to node. 2 node to node is what? One wavelength. That's what you're going to say. Antinode to antinode. Nope, nope. Antinode to antinode is what? Half a wavelength. Node to node is half a wavelength. Bolo. 2.8 can because half a wavelength 1.4 hole. Full wavelength koto hobe? Double na? Half a wavelength. You know antinode to antinode is half a wavelength, right? So the antinode to antinode is what? 1.4. Full wavelength koto hobe? 1.4 koto? 2.8. From this point to this point. They are not adjacent, by the way. This is the adjacent antinode. Clear? Clear? Online everyone, clear?
Yes.
Okay. So let me go to the next one. Okay, no. Next question. We need to.
Into the direction between.
Let me see. Okay. Suggest how the effect of hot and cold spots is reduced by placing the food on a rotating turntable.
Shop direction.
No. Rotating microwave rotate করে না ওটা দেওয়ার ফলে hot and cold spotটা চলে আসে না মানে basically problem হয় না it's not going to be a problem anymore everywhere it is hot now why it's like I think the same spot it is going to be node and anti-node at the same time if it is rotating once it's going to be node next time it is going to be anti-node so what is like anti-node then it's getting hot now
Node to our cold.
না cold node হলে cold হবে না node হলে কোনো heat reach করতেছিল না এখন heat reach করতেছে node doesn't make any difference here let's see the position of the nodes and anti-node within the forces are constantly changing one mark only one mark so or the standing wave is constantly changing position any one or the way I said maybe if you write it you will still get marks okay let's see the interference now is this a new question or something okay let's go to this we will do next class okay so today it is enough tata everyone 8:15 করে class চালু করব 8:15